I've sort of over time kind of worked on this aspect, and kind of want to share with you what I've learned, and hopefully it can apply to you and help people work faster, because we all like to work faster. So building for speed is the first point to clarify. So for me, like, building for speed is about finding either inefficiencies in process or in like the ways that you work to essentially be able to work faster, do less work, or do more of the fun stuff. So sometimes, like, parts of our work we have to do things like testing, things like make sure things like CrowdStrike doesn't happen. We have to do some testing to make sure we don't bring production down, otherwise we get shouted at, and then have a laugh afterwards. So yeah, around building for speed, what I'm going to hopefully go through is how we can use mocking to essentially find some ways of working to make things faster and easier, and hopefully less buggy too. So I sort of want to frame the reference of the talk. So the stuff here is going to be sort of front end mocking related. That's not to say that you can't do it different ways. Certainly if you've got a kind of a full stack application like Rails or Laravel, you might be better off just setting up a mock SQL database and then just like seeding that with data and doing the full end to end. So a lot of this is like the benefits tend to be where you've got a very good distinct boundary between sort of front end and back end. So stuff like Jamstack, where you might have like an SPA calls an API which has some data, or it might even be like a BFF pattern. I've used that in the past where this has been really useful. So we have some server that that's very close to the front end, aggregates some data, and then but then ultimately calls another API to actually get the core of the data in some microservice architecture. And for me, I think it's mostly around dynamic apps, and I'll sort of come to why I think this benefits mostly dynamic apps. But essentially ones that are being updated frequently and regularly, so potentially every day, every couple of hours. You've got sways of people all deploying to the same production. I think like stuff like this, I think proves really, really useful and a big benefit. So we've gone on like the building for speed, but what about testing? Now, I'm not going to go deep into testing. I want to try and keep it at the application level about how to actually apply this type of stuff. But ultimately, as we all know, software testing is a process of evaluating software to make sure it does the thing that we said it was going to do. Obviously, when we first build a function or first build some feature, we might have some expectations of like, it should work like this, often called acceptance criteria. We want to make sure it builds, but also over time, as we make changes, we want to make sure that we haven't broken anything. Certainly when you're changing maybe a low-level function that's used by a lot of things, you want to make sure it still outputs the same thing. So we have an input A, our function does something, and it outputs B. And it doesn't actually matter if the function has changed. If we give it the same input, we expect the same output. So this type of like pure code, for pure in the functional programming sense of input, the same input always gives the same output, is kind of why we might do testing. And like for me, testing itself exists in a spectrum, and part of that spectrum is towards the manual side, and part of that, the other side of that, is the automated. So everything that I'm going to show you is going to try and fit into how the highly dynamic apps, I think, can get slowed down. So that's not to say that manual testing is bad. If you have a single app that you're only going to touch once, you can build it once, well, you might as well just test it manually, make sure it works, hand it off, never have to touch it again. Like, why set up a testing framework? Why set up all this mocking and things like that if that test suite is only ever going to run once? So where you lie on the spectrum is going to be kind of based around like your experience, how you've kind of seen testing in the past, but also the application of that you're building. Like I said, one off, just manually test it. And so that paradigm of like, why is that okay? Well, for me, like, testing is about building confidence that the thing that we built does what we've just done, as I mentioned. But like every time we make a change, whether that's bug fix or a new feature, or like a refactor, we essentially are adding potential instability. And so that's what testing does, is it gives us confidence again that we're still doing the right thing. And so if you have to do that over and over again, every time you're adding a change, well, automated testing sort of is fairly self-explanatory. So for me, with that highly dynamic apps, I find that this is where I tend to sit most of the time. It's not all the way to automated. It's a big part, making sure that I can sort of focus only what I need to. If all the tests pass and the CI pipeline is green, then I can go, well, I've got confidence that the rest of the application still works. But when I actually look back on it and think about, well, how have I actually worked? Well, the processes of the teams that I've been in is that every piece of code or every kind of feature that we write, every ticket that we work on gets checked by somebody else for things like code quality and just kind of general ideas of like, is this the right approach? But then somebody will also check against the acceptance criteria in a manual way. They will pull down the branch, check, oh, is it actually doing the thing when I click the button? So my life is never all the way on the automated side. It's always going to be somewhat towards the manual. But again, it sort of depends on the application itself, and whether you're doing it kind of as a one-off. But again, for the frame of reference, we're talking about high dynamic apps, and this is the place where I think what I'm going to show you and how I've applied mocking to the stuff that I work on is going to greatly benefit. So now we've gone through what testing is. So what's mocking? Well, mocking is a part of testing. It's a technique to essentially replace code with a different implementation than is actually going to happen at runtime. And there might be different reasons why you want to do that. So some things like date and time. You want stable, predictable tests. Well, if time and the clock is always ticking, every time you run that test, that clock has changed, it's moved. So a very kind of straightforward example of mocking is date and time. We set the server time to be this day at this time at this hour, and now we know whenever we run the tests, that's when time is. We might also have unsupported code. So in the front-end world, for integration tests and sort of unit tests, we don't actually run on the browser. You can do with things like Cypress and Playwright, but a lot of the time we actually run in a mock DOM with JS DOM and Happy DOM. They take the DOM APIs that Chrome and Safari and stuff give us, and they mock them and implement them, or some of them. But sometimes what we're doing in our code isn't mocked in those libraries. So we might just go, well, put a no op in there and let's just get on with actually building stuff that people are going to use. And of course, the DOM itself in testing tends to be mocked with these libraries. And so the last one of APIs and HTTP mocking is where I'm going to focus on. And that's essentially is being able to take boundaries of your application so that we're not having to do end-to-end all the time. Often we'll find that kind of the more you're testing, the slower the tests, and we want fast tests. And so actually sometimes where you've got those distinct boundaries between front end and back end, like with an SPA, well, we can get away with a lot of just mocking the API, and then our tests will run really quick because we know we don't have to wait for a database to set up and those sorts of things. So that's kind of where this is gonna dive into. So within mocking, what is API mocking? Well, it's a process of intercepting a request and returning a predetermined mocked response, which is the same as mocking a function, really. We take some input of a network request and we change that function, say, oh, actually, don't go off to the server, I'm going to give you some data instead, and that can be instant. So an API might be internal, it might be your team that owns that API, it might be your colleague's team, if you're in a bigger business, or it might be a third party. It could be a GitHub API, those sorts of things. mocking, we can just say, well, for this test, assume that you get this data back. And so when we look back at that pure function that testing, well, the data that we input into our system will then use to determine what we render. It's a fairly straightforward SPA these days. Fetch some data, render that on the screen. If you don't have any data, display no results. If you've got some data, render a table. Whilst it's loading, render a spinner. I think we can all kind of appreciate that that's fairly typical of a front end role to achieve that. And so, well, the data is our input in that, and the HTML that we output is the output. So what we can do is we can control that input to get different outputs and see if everything's working. It feels the same as just testing a function, except now we're just testing more of it. So there are a few ways that we can implement API mocking. And these images and stuff are by Artem. I put a link into an article right at the end. He has written the MSW or mock service worker package, which I use pretty much every day. And I would heavily suggest for anyone that wants to API mock is use his library because it's fantastic. He's done an article that kind of digs deep onto actually how this works and why he went down this approach. And I've sort of just taken his images because they're really good at sort of describing like kind of different places that you can actually mock. So here we can see 3 different steps to our network request. We've got the request client, that's our front end. We might use the fetch API, we might use Axios, there might be a few other libraries there like React Query or use SWR from Next. Essentially, that's the thing that makes the request. I would like to fetch some data from this server. We've then got the environment. So that might be Node, it might be Bun, it might be the browser, but that's the low level bit. That actually makes the XHR request or network request to actually get the data. But that's fairly agnostic and most of the time you never have to touch. And then lastly, there's the server that we actually want to get the data from. So we could mock here, which is a client stub, where we import Axios and we mock that. And so whenever axios.get is called, instead of actually going to the Axios library, use our implementation, which is just going to return some data. It's very simple, it's very effective, it works, but obviously you're not testing the environments. And with Axios, there's things like request and response resolvers, which we've just now completely ignored. And so actually we're not really testing our whole system. We aren't testing end-to-end. What happens at build time or happens at runtime is now not the same as what happens in test time, which isn't great. So next we could say, well, let's push it further and move it to the environment. And that would mean instead of kind of replacing Axios, it's replacing those kind of environment libraries, the ones that actually make the request. But they're very low level and again has the same problem. We're not using what the environment is actually going to be using at runtime. And so with these sorts of things, they get quite complex. And so then you need tests for the thing that mocks your tests. And so lastly, we have the service worker. And so the idea is that we can intercept this request. The service worker API for the browser is built in. It comes after it has left your application, after it's left the browser. Essentially, it will go through any service workers which have been declared or registered, and we can say, well, don't continue on your journey. I'm going to give you some data. But now, because it's at the service worker layer, it's completely independent of environment. It's completely independent of your clients. And so we can use it across our integration tests, our end-to-end tests, in the browser for manual testing. So it gives us a lot of flexibility and is a lot agnostic to your application. Just define the endpoints, to define the resolvers, which I'll show you soon about how you actually do that. So there's sort of the few areas, but this is sort of, I think, the best place to do it for most applications. There's always a caveat there. There might be some unique instances. I think there is some stuff around mock service worker and WebSockets, but I think they're getting support for those. But ultimately, for majority of the time, this will serve you perfectly well. So, looking back to that diagram of part manual but mostly automatic, I'm going to show you how we can actually implement mock service worker into our application, and then we'll look at the automated test side, and then we'll look at manual, because, well, it makes sense that we make the most of what we do most of. And if automated tests are going to be the most common type of test that we do, let's put the effort into that first, and then we can get more benefit. That low-hanging fruit, as people love to jargon about. So how do we actually do that? Well, there's the obligatory import mock service worker. You can go onto GitHub to actually find getting started instructions on what you need to import. But whether it's PNPM, Yarn, or npm, just do that, install MSW, and that's the only library that you need. And so the way that we describe our mocks is that we have these things called handlers. So we can see a nice array of handlers. Here we have HTTP, and then there are the verbs, so .get, post, put, patch, delete, and even options that you can mock. And you can stream data as well. So if you've got a stream of like video and things like that, you can actually mock that stream, which is really cool. But you can all get the idea of, here's an endpoint. When we get a request that matches that, return this response of this JSON data. So once we've got our handlers, then we literally just call setup server, and that gives us a server. So on our tests actually run in Node most of the time. So we're not going to use a service worker for this, because service workers don't exist in Node. But MSW has this concept of a server that we can use that will essentially listen to those requests instead of actually going to the server. But it works the same. If you're on a browser, it would be setup worker here rather than setup server. So we can take that server, and then for our tests, we can just start the server before the tests start, or before any of the tests have run. We can then, after each test, reset the handlers. So that means that all of our counts and any slight test-specific mocks that we've added just get reset back to the default. So that means that every test is the same setup. You haven't got any flakiness, because state is bleeding through from one test to another, and it works on your machine, and then you put it on the CI and it fails. I think we all love when that happens, when we've got bleeding state between tests. And then at the end, we close the server down. It's pretty reminiscent of how a normal server might work. We're just doing it whenever the test suite gets started, basically. So we've got the basics of actually how we might set up handlers, but here's some more sort of examples of that. So we've got a delete here. We have a query param. So that dollar, or that colon ID is our kind of path param, query param, whatever you want to call it. And the ID is the arbitrary name. We could name it name. We could name it anything that you like. But you can see that name then gets used when we actually get that from the params on that kind of second line. We can then say, well, if this thing exists in some local map that we've set up, so it doesn't need to go to a database, we can say, well, if it doesn't exist, then return a 404. So we can actually say, well, for specific IDs, send different responses in our mocks, which is really handy. So now, again, we're only ever manipulating the data. That's the lever that we're going to be pulling on. We don't ever assert that the response of the data is okay. We say, well, based on the data, what's the output? And so here we can control, when you get this ID, return this response. And then if we've already got it, and because we're doing a delete it from that map, and then return some deleted post. It might be the ID that you deleted. It might just be okay, that type of thing that you've returned. And we can also change like the status. So whether it could be status 404, might be 500, might be 204, depending on what is appropriate for your endpoint. We can also in our path parameter, so where we've got posts, we can use a star for a wildcard. So we can say all endpoints under posts use this handler, and we can even use regex in there. So if you want to say the posts edit and post delete, use this handler, but when you just got post ID, use this handler and stuff like that. And then the only thing to remember with that is that in our handlers here, where we've got this array, it will always take the first handler that it finds in that order. So you always want to put the most specific handlers first in the array, and then if they hit, they'll use that resolver. Otherwise, it'll just keep going down the list until it gets to the end and can't find anything. So I can sort of show that here. Often, this is a little tip that I do. So often we might have quite a big REST API that has different entities of different datas. Being a robotics company, we have robots. So I want to get what robots we've got. But also at the same time, we have incidents about those robots. We have notes about those robots, and they're all entities and they're all obviously relational, but you can move these handlers into and co-locate those handlers with the kind of code that goes to fetch them, if you like, and then just import them into the file and then export them from the handlers, which then goes into the setup server or setup worker I showed earlier. And there's that wildcard that I'm showing. So I basically have at the end of mine, I always have this HTTP get star. Basically just stops it's more just because I don't like seeing the console warning that it tells me when, oh, you've got a handler which hasn't been caught. So I just put that in there, and pass through basically just means go and do the thing that you were going to do, and then we'll just return it. So actually go off to the server and actually go and make a request. So then how do we actually use or replace a mock? So the mock there is default in our test, but if we need to change it for a specific test, what we can do is we can import that server that we exported, do server.use, and then we can define handlers specific to this test. And again, because I've showed you in the setup where we've done that server.reset handlers, that will then go away for the next test. It won't exist. So you can see here, I want to change the robot so that the name is specifically RE3, and I can check that my output actually gives me a title heading 1 of robots RE3. Hopefully this is sort of explanatory of how this mocking works, and ultimately that's what we do: change the input, assert the output, which is really nice and makes our tests nice and quick. We can write them nice and fast, and then as we go forward on this talk, I'll show you how we can use those handlers that we've just written for our tests and the bulk of our work to actually make our manual testing easier as well. So no extra work, using the same handlers, the same data, only have to mock it once, but we can use it in our automated test and our manual. But I'd also like to add a bit of spice into our testing, because why not add some randomness? So entropy just being chaos or disorder. What I mean this to mean is that when we actually return some data, RE3, let's give it a random name. Let's just give it all random data that is relevant to what we're going to be returning. But actually we can increase the scope and the range of what we're going to be testing, because we're just going to give it random data and check what actually gets returned, which I found sometimes catches bugs. It does introduce some overhead of flaky tests, but ultimately the flaky tests are there because either you've given it bad data or your application is doing something that it shouldn't because you assumed the data was going to be in a certain format when it actually might not be. So I like to add some sort of entropy into stuff we're doing. Again, this is going to build into our manual testing as well. So when we look at our kind of testing approach, again, part manual, part automated, humans, when we do manual testing, are really good at a test, adapt, feedback loop. We will put something on the screen, check, does it look right? No, adjust. Go back to the screen, does it look right? No, adjust. And then we'll, that's looking good. Right, that will go from mobile now up to tablet. Right, it doesn't look good. And we do that pattern really, really well because it's something very, very visual, something definitive. It's not too much of a cognitive load. So the problem with that, though, is it can blind us to actually, we only use the same test data. We only use John Smith as a name. We only use 34 as his age. We only use that data. But when we add some randomness, we get a much bigger variety of, I forgot that, we are all biased, whether that's deliberate or not, or malicious or not. But sometimes we forget that different cultures have different defaults or different, different normals, if you like. Not that normal's a good word, but places in Asia it's not uncommon to have 2-letter surnames. It's not that common in Europe to have that. So if you then put a minimum character on your last name field and somebody can't fill out your form because they've got a 2-character surname, stuff like this will go right. It will prompt that to happen because we get a much bigger data set that we're actually testing against. So how can we actually set up reliable chaos, which seems a bit of an oxymoron, but that's where obviously pseudo-random comes into it. Most computer randomness isn't actually true random, it's pseudo-random. And actually what we can do to control how random it is by giving it different amounts of entropy. If you've ever seen the Cloudflare lava lamp wall, all they're doing there is to try and get true randomness to then give it entropy into their pseudo-randomness, which is obviously for them needs to be cryptographically secure. We don't need to be that secure. So what we can do is we can use something else. So we can just use a library called Faker, but what I'm actually going to show you I've used with Falso. It's not Faker specific, but the first thing we're going to do is import Faker. Again, the obligatory npm install, yarn install, whatever your flavor of package manager is. And then we're going to take Faker along with some custom modules, which are basically just custom faking functions. So Faker doesn't have like an incremental number that goes from X to Y, but every time you call it, it goes 1 up. Faker doesn't have that, but we can create a custom function that does that, and then we can export it with Faker so that we can then use it everywhere else, and it's seeded. And most of this is pretty much just to get the types, so it doesn't really matter too much. If you're just using JavaScript, then you don't actually need to do this. You can just put it on the custom, on a custom property. But then what we do is we seed it, and that seed key is what allows us to give us deterministic randomness. So the way the seed key works is that if you give it the same input, the order in which the output happens is consistent. So if I give it a seed key of 1, the first time I call random person first name, it will be John, and then the second time will be Alice. And if I reset that seed key back to 1, the first time I call it again will be John and then Alice. And so there's an example I'll show you in the next screen that kind of highlights that. But the last thing we need to do is re-export Faker, or our Faker added as Faker. And the reason why we do this, we put it on our own file called seedutils, or whatever file you want, is that the way that Faker and often these faking libraries do is that every time you call the seed, it resets it back to effectively 0, even if the seed key is exactly the same. So what we can do is we can call faker.seed, and every single faking function that we now use from this import is seeded. So we only have to call seed once. It's always using the same seed. Makes life a lot easier. And it doesn't stop us from using the unseeded version because we just import from Faker again. But if we want seeded Faker, then we can import it from seedutils. And you can sort of see here how faker.person first name will just be a random value. Don't know what it'll be. But when we use the seeded Faker, the first call is going to be X, second call is going to be Y, third call is going to be Z, and on and on. So how do we actually get that seed key that we add here? Well, you can be really naive and just do that. Just math.random, output to the console what the key is, because that way, when you then want to use that key from a fixed point, you can copy that key from the console and just input it into faker.seed with our key. Now we've got a consistent seed. I actually do something slightly more complex where I will put the key into session storage and then it'll persist for an hour. After an hour, it gives me a new key. So I get consistent results for an hour, and then after an hour, it gives me new things, but I can configure that expiry. Makes life nice and easy. And then the last thing that we need to do is just to make sure that we can actually import from seed utils is just in the tsconfig, add the paths, and then it'll know how to resolve that URL. And then our example again, instead of mocking, or instead of putting a fixed name, we'll just put a random person's name, and then we can check that that actually comes through. True input all the way to output. And now when you've got, because we did that console log, now when we're in tests, it's set for every suite, it will set up a new key because it sets up a whole new environment. So we've got the seed key there. So anytime I need to debug those tests where it becomes flaky, stick in the same seed key, and now we've got a consistently failing test that's not flaky. So what about the manual side? So we've set up automated, we've got a nice bit of entropy in there as well, but we aren't all the way over to that kind of automated side. And this is where we can do something which is dynamic mocks at runtime. So I built a tool that will basically take a configuration option. If anyone's used like a DAT GUI for 3 stuff, or if anyone's done any like game development, you'll often have a control bar on the right hand side where you can change stuff at runtime and see how it affects the application. So we can do the same. We can take that config that we can define, and we can change the values at runtime so that effectively we can get a really nice broad range of different data sets of random data, but then just elements of control. So now, say when you're testing a table, you want to test loading and when there's no results, because no results and loading aren't the same thing. But then you also might want to test the other extreme of there are 1,000, there are 1,000,000 rows being returned in your table. How does it handle that? Well, instead of having to go to the mock and do copy, paste, copy, paste, copy, paste, we can just change the number. And I'll show you what that looks like. So for this example, I'm going to take you through this, this idea where you've got a get user and a get users. Fairly common for an application. And I'll show you that example of how that dynamic mocking at runtime. If I can bring up the right slide. So we've got a nice demo application here. We've got a user, and then we've got a list of users. I can actually change how many users there are being mocked if it wants to do it. He says. There we go. So I can keep adding and adding and adding, and like, oh, my app's broken because I haven't coded very well. But I've just changed that within a blink of a second, and I can also then go, well, what happens if we have 0? Again, that's how it looks. So we can rapidly change, and this works really well for making sure that we don't get regressions or that somebody's doing that manual testing on that ticket. We can just change the data that we need to on the fly. Here we've got a blank name, but like I know that, what happens when we've got a really stupidly long name. That's how it looks. You can do that on the fly, haven't had to go back into the code, haven't had to change context away from this. And we can even do things like, well, what happens when we're admin? And obviously you can really see, well, a lot of things might change when the user's an admin, and being able to change that on the fly and look at 2 different sort of contexts. I found something really beneficial. So coming back to our tool, here's the changes that we've made. So now, instead of having an array of handlers, we're actually going to have an object. And the reason for that is because we can use the property name as the name in that tool. That's pretty much the only reason why. And then we wrap our options with 3 different things. So I can sort of show you side by side both endpoints that we're going to mock. So the first thing is we have this function called with options. And the first argument that takes is a config object. So this is the settings that you've just seen. So for the amount, for the array, and then the name, age, and whether they're an admin. And I'm using a tool called Lever here for the like the GUI. It has some configuration options where if you give it an array, it'll be a select box. If you give it if you tell it's a vector, then it'll be a vector. If it interprets that it's just a number, then it'll be a number, and you can change like the steps and the min max and stuff like that. So you can sort of set up that. The next function is like the mock data that you want to return. And the reason for this is we put it here rather than inside the resolver because now that we've got random data, we aren't returning the same data every time it's called. We're just returning random data. So we want to make sure that we can have the opportunity to call it once and then essentially close over that faked value in our tests. So now we are getting fake data, but it's the same one every time. And that config of like config.name, that's when this function's called, those values will be the values in the UI that you put. John Smith, and they're an admin or not an admin. Those will come through when we're building the fake user out. And then the last thing is instead of returning a handler specifically, we return a function that returns a handler. And we have this function that gets returned called getResponse. And essentially that's responsible for getting the data when the mock is called. So we do some cool stuff under the hood with React to essentially like use a ref to manage like what state it's in. But because with React and like the ref.current is a getter, so it's only when you call .current that it'll get that data. So we can essentially close over a function that gets the data and then pass it into here. If people do want like a deeper dive onto this, like I can do it because it's a really good example of like how closures work. But hopefully this doesn't feel too dissimilar of like, oh, here's some mock data, we're going to return it in HTTP response. And then we do the same thing. So here's the old thing on the left, and here's the new thing on the right. We have this create static handlers. And again, that's so that we can generate the fake data when the test starts, and so that every time that function's called, we get the same data back, but it's random each time for each entropy or each test. And then we set up the server, and we just pass in our static handlers and any other handlers that might not be using this. So the kind of MSW handlers will still work with this. There's nothing breaking there. And then we add the tool to our application. We tell it we want it fixed on the bottom right, but obviously you can put that anywhere you like. We pass in our handlers. We pass in the basic handlers, just kind of the MSW handlers, and it sets up the worker for you. You don't need to do anything. There is even like an on-initialized callback that I haven't shown here, so you can hide your application until your mocks are loaded. Useful if you've got like server-side rendering and stuff like that. And then what I do, because I tend to use React Query, is like whenever an option gets updated, I just invalidate the cache. So whenever the cache is invalidated, if that query is still like being subscribed to, it'll just go fetch the data again, which means our mock gets hit again, and then we get the new fake data. So but it doesn't have to be that. You could just reload the page. So change the mock, change the values, reload the page. The config values are stored, so the reload will pick up on the current values. You don't specifically need it, but like React Query just makes life a lot easier, and we just invalidate it. And then that basically allows us to do that, to get that like dynamic mocking at runtime. And I'll actually show you a bigger demo. So this is actually what we use at work. This is what I'm building with my team. And I often find that like examples like this are useful. They're like, simple enough to get your head through, but they don't go through the nuances of like, oh, what happens when you dig into the deeper, like how does it look like as a more mature kind of tool? So I'm going to take you over to here, and I've got a lovely error page, and that's good. I've not got any server running. So how am I going to get data? Well, if all of our data, all of our kind of data that's, this is an SPA app, so we need all the data that we needs to come from an external source. How am I going to do any work when the internet goes off, or I'm on a train and I don't have an internet connection? Well, because we're mocking, I can just turn on the mocks, refresh the page. Oh, look, our app fully working, all because all this data is mocked. We want to get robots because we want to get more. Oh, we've got more robots. You want 500? Oh, look, we can see that, for now, we've got a nice big list. Still going. And there we go. So we can actually see that, like, there's a bug here. We should only be showing 30 and we're showing 500. There you go. Bug already. It's probably because I was working on this today. But, like, you can see how simple it is to just spot this. Like, if you had to test this manually, would you find this edge case? And, like, majority of the time is you probably would. It's a fairly obvious problem. But actually, a lot of the times, stuff like this will slip through the net because, like, we just assume because of our automated tested that this is working. And so actually we can find with bigger entropy these types of bugs and go, I've got an automated test that's lacking some coverage. I'll go and write one, so now I don't have to test this again. We can do a lot of cool stuff as well. So when you've got, like, really sort of dynamic stuff that's based on, really dynamic data, we'll go into this robot. We go to there, and we've got all this different data about, like, whether it's on a mission of, like, whether it's actually scanning a rack, what its CPU usage is, what its disk usage is, those sorts of things. We have a lot of data with LiDARs. They just take up gigabytes of data. So how do I, like, test? Because these colors are supposed to change when you're getting full. So I can go down to our storage, change it to 95%, and it's full. Oh, I want it to be, instead of 2 gig, I want it to be 20 gig. There you go. And I've got 95% of full. I can change it back down to 30. So these dynamic mocks, just a really, really handy way of utilizing our kind of automated test mocks that we need for the majority of our work anyway with automated tests, but now we get to use them for manual testing as well, which is really handy. And we can even turn things off. So, like, what happens when it's undefined versus just true or false? So we can say, well, like, we don't know what the doc status is because it returned undefined for some reason. We can change what environment it's in. And obviously you can see, well, like, what happens when you're looking at something from an admin's perspective. We might have different buttons that appear that you can do different stuff on. Like, only certain people can like pin it to a release and things like that. So we can just change, like, who the current user is. And this sort of tool of this dynamic mocks isn't specific around mocks. Like, we can change anything, like, within application state at runtime. But when paired with mocks, we haven't had to write anything extra, but we've got this. One thing I was going to show you, actually, just before we finish. A lot of this that I've spoken about is about getting data, but what about, like, posting data? Well, you see here, we've got a post notes kind of control, and I can actually change the response that we're going to get from that endpoint. So if I go to our notes page, we've got an add note, fairly self-explanatory, hello staff's web. I'm going to hit save. Successful, because we said we want a 200 back. But what if we want to mock that there's a 400 error because that there is an issue? And sometimes, like, when you've got like good validation, it can be hard to actually, like, manipulate this scenario from happening. Certainly with 500 errors, how do you, like, mock that a 500 is going to actually happen? Because, like, the server might just be down for a random reason. So I'd have to go and actually either turn the server off to mock a 500, or in my mock say just for this manual test now, return 500. So now when I do it, I've got a 400 request, a 400 response, because that's what I told it. Now I've got a 500, and that's taking the error that we actually get from the mock. And then lastly, we can actually, with this path through, all the options have this toggle to pass through. So now if I actually make that request, it will actually make a request to the backend. So I can control which mocks are enabled at any time. So you can have some real data from the server and some mocked, which is really useful when you're building out a new feature and you want to have a particular scenario for this page, but everything else you don't want to have to like turn on and off all the time. So you can just like go dink, 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 I only want these to be mocked. So that's the demo. I've been using it a lot. It's been built up over the last few years, and for me, it means that I can change that lever to test different outputs, whether that be an automated test or in manual. I get that faster feedback loop. I get that prototyping as well. With sometimes you're working on a feature and you don't quite know what data you might need because you don't know what the UI or the user experience is actually going to be. So you can just mock, it's going to come from an endpoint. So you just mock an endpoint out, get the data, return whatever data you think you might need. Your application flow state stays the same. And then with TypeScript, if suddenly you make a change or you delete something that actually your application needs, TypeScript will tell you. And at the end, once you go, right, I've got the user experience how I want it, right, here's the contract that the backend needs to build to. Or you can do an approach of like, what data you've got and what you're going to return. And so your front end and your back end can build an API spec, a contract, and you can both go off in the same direction, at the same time. You can build a mock to that spec. The back end team can build that API endpoint that will return data that matches that spec. And now we can finish faster because we haven't had to wait for somebody else to finish their part. I can go and build it without stopping. And again, that no network needed. If the internet's out, if you want to train, just turn on the mocks and away you go. The response time of a mock is instant. You can actually add delays in there as well that are controlled. So if you want to mock slow requests, you can do that as well. So yeah, there's kind of really useful thing, but it's all built around that idea of mocking data, that lever that, most applications kind of flow through. Get some data, determine what to output, and then output the right thing. So why not have a tool that can manipulate that lever to make testing easier, whether it's manual or automated? As I mentioned, that's the blog from Artem, the kind of author of MSW. He spends a lot of time digging into this. It's a really useful tool and probably one of the best kind of open source tools that you'll ever come across. So he's gone into a deep dive about why he chose Service Worker and how he made it fit. Really, really good. It doesn't take that long. And then obviously there's the lava lamp. What is entropy? That's just a nice read. And that's that. Yeah. Is there any questions? Hopefully I've kind of followed you along. Yes, at the back there. I can hear you in person, but...
when you're working with a big system, it's very easy when you've got a very small system to do this, difficult to do it. How do you maintain, you've got a really complicated system, here at Craigslist, our JSON responses are literally megabytes sometimes. There's so many different properties, so many different flags, especially working with the backend team who are maintaining the template. How do you maintain that, and worry that I set it all up, do it all great, and then in a year's time, the mocking is now actually just not a representation of what production is, just because the backend's completely changed it, and they don't have any response, they don't actually use it, so they're not updating it. So is there any tips and tricks on how you do that? I know it's quite a question there.
Yeah, so just in case everyone else didn't hear, how do you kind of keep the mocks in sync as the real responses change over time? I think is a fair summary of the question. It's a good point. Anything that isn't runtime is extra kind of burden. It's same as documentation. If you have to keep a one-to-one, it's a pain in the ass. So the way that we do that is by enforcing it. So we build out an open API spec. That's what we write. That's how we write our endpoints. Is a Swagger file, and then we use that to auto generate a client. So the mocks are typed to that data type, if you like. So let's see if I can show you. So in our API types, this is a generated file. So I haven't had to write this out. It comes from the Open API that's generated, but you have these like components that get output of like your different schemas and stuff. So here we have like the robot status of enums, but then you've also got. Oh, I'm not, am I? Thank you. So let me start again. So we've got this generated file, and it generates out some types, and you have these components that it gets output, and so here you've got a user. So if I actually go to our user mocks, so I like I said, I set it up how we do that. So API user handlers. So in our handlers, we've got this create mock user, and that create mock user takes in a partial of a user, which means we can overwrite all the values, and then here's all the default, and it must return that. So every time it changes, you update the mock. And like, actually, when you look at how often your data structure changes, it's not that often. You will add new things, and that's fine, and you just get told off because TypeScript says, "Oh, you've got an error here because this object isn't returning enough." And actually, that's really simple. If you do have big JSON kind of responses, often those big JSON responses I found like built up are different entities because they're relational often. So you'll have like the robots and their incidents. And so actually when you start breaking it down into those entities, you only need like create a mock robot and create a mock incident. And then just when you're overriding the mock, incidents is an array of these create mock incident. So you can build it up that way so that you're not having to write loads and loads of stuff. Hopefully that answers it. Again, you can sort of co-locate stuff together. So we've got all the handlers and then all the mocks and then kind of the thing that does the fetching. So get the list of robots, get a single robot, delete a robot, all those like front-end APIs. And most of the time with like REST endpoints is like this data, like this is React specific, but it's not specific to this application. Any application that's calling that endpoint or that API could just import this as a package. So you can do stuff like that as well, where actually the API functions themselves should be completely independent from application logic, because like calling an API isn't application specific. Yeah.
I had another question, if it's all right. How would you compare this versus doing this on the database level? Because when I've spoken to like backend developers, they're like, yeah, that's great for front end, but like we want to do the same. There's a lot of application logic that's in the back end, especially when we're on our front end. We try and keep it very business logic lean on the front end and push as much kind of application logic into the back end because people have different front ends and stuff. So would you do the same thing on the database level? Was that something you explored, or I don't know, just curious?
The answer is it depends. So I've worked in the past at Boomin. We had microservices. We had maybe a few hundred and about 30 different micro front ends. So when you start trying to test and mock out databases, all those interdependencies of microservices, it becomes a pain to actually set up. So often people don't. But if you've got an end-to-end application like a Rails app or a Laravel app that isn't microservices, then actually, like setting up a mock database and like spinning up either an SQLite if it's in Node or something might actually be a better option because you're still going to get fast response times. You might have to start a second process of a second server, but you haven't lost out on that no network connection because everything's obviously on your machine. And then you're actually getting proper end-to-end all the way, and that might be the way to go. But often with this sort of SPA where it is a front end, you've got that distinct boundary between front end and back end. That's where these sort of mocks come in use. We've got a Rails app at work, and they mock out the database. Like Rails has got some really good utilities for doing that. So every test has its own sort of like environment with database that gets seeded randomly, so that they're basically doing that. And it just depends where you want to draw the lines for your integration. Like this idea of like unit versus integration versus end-to-end is so subjective, because it's about where you draw the boundaries of what you want to test. Unit testing is nice and easy because it tends to be just a function, but like you wouldn't unit test just an entire endpoint. You'd class that as then integration. So all we're talking about is semantics of where the boundary is. So for me, on front end, we can draw a very easy boundary at where like it leaves the application, and then we can scope it to that. But actually, if you've got a Laravel or a Rails app, that boundary might not exist. So yeah, just mock it at the database. But it sort of just depends on your application of your application.
Thank you. I really like that answer. I think I'd agree on that.
Yeah. Any other questions? Cool.
All right, so thank you so much. Great. It's 8 o'clock, so we'll have a little break. Anyone not done open discussion before? Anyone done it? You guys done it before? Yeah, you know what happens. So I've got some post-it notes on the table over there. Please pop some questions, topics that you'd like to discuss, and we'll come back after the break. What do you reckon? 15, 20 minute break? Something like that? Yeah. And we'll get started with the discussion. Thanks so much.